In class example 2.24, we'll use synthetic division to factor a polynomial. Here we're given p of x, described as a cubic function, and we're told that one of its factors is x plus 3. To be a factor means if we divided p of x by x plus 3, we would get a remainder of 0, so it divides evenly. Now we won't worry about the graph to the right yet, we'll get to that in a second. For now, let's set up our synthetic division and figure out what the quotient would be, which is to say the other factor when we divide by x plus 3. Remember, we're always checking to see if there's a term of missing degree, but here we have x to the 3, 2, 1, and 0. Everything's accounted for. We write as our divisor minus 3 because that's the 0 of x plus 3. We drop the 1 and multiply, and add, and multiply, and add, and multiply, and add. We find the remainder of 0 as expected. The term to the left of that is the constant, to the left of that is the x, and to the left of that is x squared. This means that x plus 3, if multiplied by x squared minus x minus 2, would return back x cubed plus 2x squared minus 5x minus 6, the original polynomial. Now we need to factor the quotient. We have many strategies for this that we practice in Math 10 and 20. Given that this trinomial, x squared minus x minus 2, has a lead coefficient of 1, we simply need to find two numbers that add to negative 1 and multiply to negative 2. We find x plus 1 and x minus 2 in either order. With this, we have found the factored form of our cubic polynomial. Remember that the zeros of the function will be the opposite signs of what we see in the brackets, which is to say, if the factor is x plus 1, the 0 is at minus 1. Graphically, this means that we'll see the curve, the polynomial, the cubic function, cross the x-axis at three places: negative 3 and 0, negative 1 and 0, and positive 2 and 0. If we want to determine the y-intercept, that would be a different process in which we would simply evaluate when x is 0. We could do that in either the original form or the factored form.